we can now reach directly into an AI's architecture to physically dial up specific cognitive behaviors, like analytical reasoning. Connecting a steering backend to a standard chat interface allows us to transform a basic descriptive response into deep causal analysis by adjusting a single number. To follow this workflow, you will need a running miLLM server with an active model and sparse autoencoder connected to Open WebUI. Mastering these steps moves us beyond traditional prompt engineering and into the direct programmatic control of AI logic. The first step is identifying the specific neural feature we want to control. Inside MechInterp Studio, we have located our target, feature 4476. The details modal identifies this as the analytical explanatory pivot. Its function is to force the model to move from stating facts to explaining why things happen. This feature activates on specific connective tokens, like conjunctions, which the model uses to bridge descriptions and explanations. Understanding the mechanics of this pivot is essential, as this is the exact logic we will be injecting into our chat interface. We now route our standard chat interface through the specialized steering engine. In the Open WebUI settings, we navigate to the Connections page to establish the API link. We input the specific miLLM backend URL to ensure the chat requests are processed through the steering engine. On the miLLM dashboard, we can verify that the model is loaded, the autoencoder is attached, and the steering component is active. This architecture allows the user-facing chat app to treat the engine like a standard API, unaware that the output logic is being rewired in real time. To measure the impact of our steering, we must first capture a baseline output. In the miLLM backend, we confirm that our target analytical feature is currently set to a strength of 0. We send an ambiguous test prompt about students failing an exam. This scenario is designed to have multiple valid interpretation paths. The baseline response follows a standard descriptive structure, providing a textbook-style list of reasons for the failure. This baseline establishes our control variable. The shifts that follow originate from the internal feature steering we are about to apply. We begin the first active steering phase by dialing the feature strength up to 0.4. It is critical to start a new chat session now. This prevents previous responses from polluting the model's context for the new test. The response generated at moderate steering shows a distinct shift. The model begins to prioritize psychological factors and metacognitive framing, such as groupthink. We can escalate this effect by pushing the feature strength to 0.8. After clearing the context with another new chat, we send the prompt again. At this level, the AI has abandoned simple descriptions. The output is now heavily mechanistic, focusing on specific explanations like cognitive load and the difficulty of replicating exam conditions. This highly diagnostic output is the direct result of our internal manipulation, standing in sharp contrast to our original baseline list. We have altered the model's reasoning mechanics without changing its weights or the prompt, solely by amplifying a single internal feature. We have transformed a generator of simple lists into a complex diagnostic reasoner. This capability allows you to integrate deep feature steering into your standard daily chat workflows. You can continue this experimentation by identifying and manipulating other features in the miLLM dashboard, such as those controlling brevity or specific coding styles. We have moved from conversational prompting to neural manipulation. We are now tuning the mind of the model.